Alright, this tutorial video is all about introduction to transformations. So, triangle XYZ is transformed to create triangle X prime, Y prime, Z prime. The lengths of both triangles are shown. Is this a rigid transformation? Explain. Well, what's a rigid transformation? A rigid transformation is a transformation that preserves the size, length, shape, lines, and angles of measure of a figure. So if it's rigid, and another name for that is isometry, all the lengths and angles should be the same. So looking at the corresponding lengths, 10 and 10, 9 and 9, 4 and 4. The corresponding lengths are all the same, so this is going to be a rigid transformation since the lengths did not change. So which one of these answers was correct? Yes, the pre-image and the image have the same side length measures. Yeah, that's the reason. Yes, because all transformations are rigid? No, there are transformations where you can go from a small figure to, say, a larger figure. That's called a dilation. Okay, so that would not be right. And of course, the ones that say no are incorrect. All right, so that's why that was the answer there. All right, let's go on to the next one. Triangle ABC was translated to form triangle A prime, B prime, C prime, as shown. Which describes the transformation? Check all that apply. The markings tell us that the corresponding sides are all equal. All right, this is a single mark and this is a single mark. That means these are equal in length. This is a single mark also. Technically that means that this is an isosceles triangle, meaning that they're equal to each other, but that doesn't really matter right now. What matters is that AB and A prime B prime are the same length. Okay, so those are the same. And then looking at CB and C prime B prime, we have a double mark and a double mark. That means those are the same lengths. And similarly, the angles they're all marked the same. You know, A is marked the same as A prime, C is marked the same as C prime, and B is marked the same as B prime. So all of the corresponding sides and angles are equal in measure. So that means this is definitely rigid. Okay, so that means it is not non-rigid, all right, because those are opposites. So you can forget about non-rigid. Isometric and rigid mean the same thing. So those are always going to go together. The size is preserved. Yes, again, rigid and isometric means all the size is preserved. Okay, the angles are not preserved. That's false. The angles are preserved, as we just discussed. So that's no good. So these three are the answers. All right. Let's move on. A transformation of rectangle LMNO results in a new triangle L prime, M prime, N prime, and O prime, as shown. Which transformation maps the pre-image to the image? Okay. So this is the pre-image over here, and this is the image. So they want to know what kind of transformation it is. So dilation, stretch, reflection, or rotation. Well, we can eliminate reflection and rotation right away. Look at the order of the letters. Going clockwise, we have L, M, N, O. And going clockwise here, we have L prime, M prime, N prime, O prime. So the corresponding angles the corresponding vertices are in the exact same order and the exact same position. So that means that there was no reflection happening. And as I mentioned, they're also in the same position. Like L is in the upper left-hand corner and L prime still in the upper left-hand corner. So there was no rotation that happened or anything like that. So it's between dilation and a stretch. So it would be a dilation if all of these sides increased at the same amount, okay, or decreased technically. But notice the 4 and the 4. Those did not increase. Only the length increased, all right? The 8, well, did I say increase? Decreased, all right? It went from 8 to 6. So since all of the sides didn't change at the same time, it's not a dilation, all right? So that just leaves stretch. You can have a stretch where the shape only changes in one direction. It doesn't have to change in all directions. So it must be a stretch. All right, again, dilation would be an equal increase in all or decrease in all directions. Okay, next one. Which description is true about the transformation shown? Let's look at the transformation first. Let's look at the lengths of the sides and the angles. Are the lengths the same? No. Okay. 4 and 8, 2 and 4, 6 and 12, 2 and 4. The lengths doubled if you look at it in this direction, or they were cut in half if this is the pre-image and this is the image. But the lengths are different. They're not the same. All right, so right away we know this is not an isometry. This is not rigid. Are the angles preserved? Sure. All right, this angle and this angle are the same. All right, because of the markings. This angle and this angle are the same because of the way they're marked. Okay. See the double mark and the double mark here? That means these are the same. And again, double mark, these are the same. So all of the corresponding angles are the same. So the angles are the same. So this is not rigid. So what kind of transformation could it be? This would be a dilation. Because yes, the lengths change, but they all change the same amount. If this is the pre-image and this is the image, every single length doubled. So that would make this a dilation. Okay. So it is a dilation because the transformation is isometric. That's false. The transformation is not isometric, so that's false. It is a dilation because the transformation is not isometric. Maybe. Okay, it is a stretch because the transformation is isometric. Yeah, stretches are not isometric, so that doesn't make sense. It is a stretch because the transformation is not isometric. It's not a stretch because all of the lengths changed together. So that's how we know it is a dilation. It would be a stretch if only some of the sides changed, but meanwhile some of them stayed the same. Okay, so it's not a stretch, it's a dilation because they all changed. Okay, there you go. All right, a transformation is shown in the diagram. And then we've got these questions. Which transformation is shown? Okay, what happened? It looks like these are congruent, all right? They seem to be the same size. You know, the lengths seem to be the same, and the angles seem to be the same. But something happened. it looks clear to me that this is a reflection, like these are mirror images of each other. Okay, so you see F and F prime, see how they're close to each other? But then E and E prime are on opposite sides, all right? It's backwards. So this is a reflection. You know that this is not a rotation because if you look at the order of the letters, all right, if I go clockwise around this shape, I have E, F, G, D. Okay, I'm going clockwise. Now if I go clockwise around this shape, starting with the corresponding point E prime, I have E prime, but then I get to D prime, and then G prime, and then F prime. So even though I'm going in the same direction, clockwise, the order has changed. That's another signal to you that there has been a reflection. All right, if the order of the letters change, there must have been a reflection. All right, so I'm sure I've answered the question in here somewhere. Was it translated? No. A translation is just a slide, and it wouldn't change the order of the letters like this. Okay, it wouldn't make it backwards. So no, it wasn't a translation. Was it rotated? No. As I just described, a rotation, again, would not change the order of the vertices. Was it reflected? Yes. Okay, was it dilated? No. If it dilated, the size of the lengths would change. The sides would be bigger or smaller. All right, so we are looking at a reflection. Okay, so again, just to be clear, because I see that this one was chosen by somebody, translated means it's just slid across the paper. Okay, the not flipped backwards. Okay, I think this is the last question. Triangle 1 undergoes 4 different transformations. The results of these transformations are shown. Which statement best describes one of these transformations? Triangle 1 is rotated to result in triangle 2. Okay, is that possible? Triangle 1 is rotated to be triangle 2. All right, I'm always nervous when the very first one seems to be the answer, but that does seem to be the answer. Okay, let's check it out. I can cheat a little bit by tracing this picture and then rotating it, and we can actually see what happens. So here's the picture. So the question is there a way that I can rotate this and then have it match picture 2? And there you go. I just did a little bit of a rotation, and then now it matches picture 2. So the answer seems to be the very first answer. Okay, let me put that aside. Now, if it was, could it be dilated to result in triangle 3? Okay, so we're looking at triangle 1 to triangle 3. Well, clearly the size changed. But the problem is the sizes don't change equally. If it's dilated, all the sides should change in the same way. But it looks like only this side got smaller. Meanwhile, this side, the green side, is still the same size. So that would not be a dilation. That would be an example of a stretch. All right, if you have one length changing while the other length doesn't change, that would be actually a stretch. Okay, so from triangle 1 to triangle 4, let's talk about that one. All right, triangle 1 to triangle 4. That would be a translation. All right, okay, 1 to 4, you could imagine just sliding this triangle across the page. the sizes are not changing. Would this be a reflection? No, because it's facing the same way. It's not backwards. Okay? If triangle 4 looked like this, now it could be a reflection because of the way it's backwards. Okay? Like this could be the mirror image here. So it could be a reflection if it was this shape, but it's not a reflection. Triangle 1 is stretched to result in triangle 5. Okay, again, a stretch is where some of the lengths change, but some of them don't. But from triangle 1 to triangle 5, all of the lengths changed in the same way. Let me see if I can cheat again and show you this real quick. Triangle 1 to triangle 5 looks to me like a dilation. So if I take this shape and blow it up equally all around, now it matches triangle 5. So that's a good example of a dilation, not a stretch. All right, I hope this video was helpful. Good luck on your quiz.